Welcome to day one of my Codeforces journey. So here basically I go to this site c2ladders.com something.com. By the way, basically I choose 800 difficulty rating and choose the first one, Polycarp and coins. I solved 2, 5 and something more before. By the way, let's start from scratch. So this is the first one, Polycarp and coins. So here it says that, okay, let's zoom it a little bit. Polycarp must pay exactly and barrels at the checkout. He has coins of two nominal values, okay, one barrel and two barrels. Polycarp like both kind of coins equally, so he doesn't want to pay with more coins of one type than with the other. Fine. And thus Polycarp wants to minimize the difference between the count of coins of one barrel and two barrels. Okay. uh, Being used help him by determining two non-negative integer values c1 and c2, which are the number of coins one barrels and two barrels respectively. Okay, it says basically help him by determining two non-negative integers c1 and c2. Basically I have to find c1 and c2 values, which are the number of coins one barrel and two barrels. Okay, so that the total value of the number of coins is exactly c1 plus 2 into c2 equal to n, and the absolute value of the difference between c1 and c2 is as little as possible. Okay, mainly I have to take the minimum value c1 minus c2. Okay, that's fine. So this is the equation c1 plus 2 into c2 equals to n. Basically I think this n will be given. Okay, each test case consists of one line. This line contains one integer n. Okay, this is the value of n which is given in the input, and so I have to calculate the value of c1 and c2, and c1 plus 2 into c2 equals to n. So I have to print the value of c1 and c2 basically. So those values are c1 and c2. So in the note, it explains the test case 1, basically first test case. This one, here's the value of n is 1000, and it says c1 value is 334 and c2's value is 333. The sum of the nominal values of all coins is 334 into 1. Basically this equation c1 into 1, okay, 2 into c2, 2 into c2. Okay, if here the c1 value is 334 and c2's value is 333, and if we calculate this, the answer will be 1000, which will be the value of n. So here's 334 minus 333. If we subtract it, then the resulting value is 1. So this is the minimum value, since I have to take the minimum one. Okay, so one can't get the better value, because c1 absolute value of c1 minus c2 equals to 0. Then c1 is equal to c2, and c1 dot 1 into 1 plus c1 into 2 is equals to 1000, but then the value of c1 isn't an integer. Okay, so here basically says then the difference is the minimum. Okay, so in the second test case, the value of n is 30. So the answer for the second test case is 10 10. c1's value is 10 and c2's value is 10. So the number of the nominal values is 10.1, 10.1. Okay, sorry, 10 into 1 plus 10 into 2, basically C1 into 1 and C2 into 2 equals to 30. That's right. And the difference between absolute difference between it is equal to 0. So whereas there's no number having an absolute value less than 0, so this is the minimum difference. So basically what can I do now, that this is the value of n and this is the value 30, so all of those values are n. So here n is 10 to the power 9, so I can take integer as my data type. And okay, why they take 334, 333, and those values are close each other, and here also 10, 10, those values are equal. Okay, C1 equal to C2. Okay, and okay, fine. So why they take 334 and 333 to calculate the value, to calculate as the resulting value is equals to n, means 1000. If we divide thousands divided by 3, what happened? Let's check. So okay, let's zoom in little bit. How can I zoom it? I don't know, by the way. Node, if we divide 1000 by 3, so I can get 333. Okay, that's the value of C2. Okay, I get the value of C2. Fine. And in this case, those both of those values are same. Okay, also I have to take the minimum result. The answer for the second test case is 10, 10. Okay, there is test cases. For each test case, output a separate line containing two integers C1 and C2, separated by a space where C1 is the number of coins of one barrel and C2 is the number of coins of two barrel. If there are multiple optimal solutions, print any one. What this line actually mean? One can't get the better value because C1, if C1 minus C2 is equal to 0. Okay, so here C1 minus C2 isn't 0, it's is equal to 1. Okay, and then C1 equal C2. Here in this case C1 and C2 are equal, basically 0. Okay, and the final one is C1 into 1 plus C1 into 2. Okay, but then the value of C1 isn't an integer. Okay, okay. What if I divide it by sorry, divide, not divide actually, modulo by 3, modulo by 3, 1000 modulo 3, I get 1. Okay, 1000 modulo 3, I get 1. If 10 modulo 3, I also get 1. Fine. Okay, okay, okay. So I can say that if 1000 divided by 3 is the value of one value, for example c2 is the value here, so I can count it, or I can take the floor value of it for count as a c1. So this is the c1, and if I divide 10 by 3, I also get 3, so 3. Okay, 10 divide 3. Okay, let's take the initial setup, then I will get back to it again. So documents, then Codeforces 800. Okay, what's the question name? So this is the question name, so open it. Nano, fine. So here so at first take integer hashtag include bits plus stdc plus plus dot h using namespace std. Font size is very small. Preferences, okay, so what is the font size? Okay, font size is 12, so I have to increase it 16. Okay, that's fine. So then this is the main function, integer t for the test cases, int while t minus minus. Okay, here integer n, basically in right shift n. Perfect. So I take the value of n, so this is the time I have to calculate the value of c1 and c2. Until now I don't I can't figure out the logic, but I start my coding. By the way, let's close this main function and close this while loop here. Okay, then go back to this one. Fine. So what will be the logic? How many time I expended? 13 minutes. Okay. 334, this one. Okay, let's do a little thing, that if I divide a value divided by, if I divide the value of n with 3, I get the value of this. Okay, so let's start with this one. So so I can say integer c1 is equal to n divided by 3. So this is the value of c1. I can say since both of those values are same, but the difference between it is 1 actually. So if I see those resulting value, and this one is 334 and this one is 333, the difference is 1. and those difference is same. Those difference are same, because those values are equal, and the difference between them is 1. The difference between them is 1, and the difference between them is 1. Okay, also here is 1. So only for this one is the same. So I can say that if I divide a value with 3, I can get a number. Okay, for example, if I take another, for example, 32. If I take 32 divided by 3, what happened? 32 divided by 3, 10.6. Okay, okay, I get 10. So 10 is the C value of C1. Okay, I can say that integer C2 is equal to C1. Fine. Now what can I say? What can I say? If I modulo 32 with 3, then I get 2. Okay, I get 2 here. 32, yeah, 32 divided by 3. So 32 modulo 3, I get 2. Fine. So okay, if I divide, sorry, modulo 333 modulo 3, I get 0. Okay, I get two response. One is 2 and one is 0. Okay, let's take another one. If I take 10 modulo 3, I get 1. So there are 3 responses. Okay, so if I take this value, for example, okay, get back to my terminal, modulo 3. So here I also get 1. So for 10 and the large value, I get the value answer as 1, and for 333 I get answer as 0, and for 232 I get the answer as 2. So from this, what can I decide? Okay, 33. mm, until now I take the same value C1 and C2. Okay, so let's take the steps one by one. For example, 333. If both sorry, if the resulting value is 1, so what can I print? So 10 modulo 3, the resulting value is 1. Okay, and 333. Okay, so what can I decide from this? Okay, let's take not 333 for this. I will take 334. So here I get 1, because 333 is the value of C2, not C1. So C1 is 334. I get 1. So I can say that um, if the answer is 1, then I can print like that. Okay, but don't know what happened to the second one. Okay, and okay, let's try. If um okay, what is the logic? C1 modulo 3 equal 1. So if this is the case, we get 1 as the output. So I can say that uh, C1 is the, sorry, the value of C2 is equal to C2 is increased by 1. Okay, that's fine. Okay, if C1 modulus 3 equal 2, so what happened, and where I get 2, where I get 2 this one, so 32 is this one. So for 32 I get the same value. Basically I think I do a wrong thing. This will be C1 and this will be C2 plus is equal to 1. Or on the other hand, I can just print cout C1 C2 and line. Fine. So let's run it. G++ a. Okay, run, copy. So I get what answers? 1031. Okay, those are the input and those are the output. So here I get G33 11 00. None of these answers are correct. So where I did the wrong part. So let's open it here. Nano a. Okay, so here basically I get both values same, but this is not the case. Okay, okay, so where I did mistake. 3 all the values are same. Why? So here okay, oh sorry, actually I copied this the same thing basically, and the value of C1 is the value of C2 here. Okay, so here if C1 modulo 3 equal to 1, so C1 is this, C1 modulo 3 is equal to 1. So what I get here, 334 modulo 3, 334 modulo 3, but I didn't get 334 actually. 1000 divided by 3, yeah, 333. This is the answer. I think I need to take the floor value. Okay, so let's find C++ floor function. I forget how to call it. Floor C++. Okay, basically, oh, as just as simple as I think. Okay, this will be here, floor. Okay, fine. Now if I copy and run the test case, now G++ a, run. Okay, now I get, oh sure, shit, again the same answer. So where did I do the wrong thing? So here floor n divided by 3, C1 C2, C1 modulo 3 equals to 2, and C2 plus is equal to 1, C1 and C2. I can't find any logic here. Okay, let's start that reading the tutorial. So In a tutorial, it says let's initialize variable c1 and c2 by the same value. Okay, I am right. Same value. I also take the same value. Okay, here also it divides n by 3. Okay, it's the floor value. Recently, I take the floor value here. Okay, then we need to gather additionally the remainder of dividing n by 3. Okay, so what they do actually, mm, if the remainder is equal to 0, we don't need to gather anything else because the variable c1 and c2 have been already set to the correct answer. Okay, if the remainder is 0. Okay, fine. And okay, if the remainder is equal to 1, then we need to gather additionally 1 barley using 1 coin for 1 barley. So let's increase c1 by 1. c1 c1 is equal to c2 plus 1. c2 plus 1. Okay, and if the remainder is 2, then c2 is equal to c1 plus 1. Is this the mistake I did? uh, Here I type c1 plus is equal to 1. If I take this, c1 is equal to c2 plus 1. Okay, and for this c2 is equal to c1 plus 1. Okay, let's try it now. Copy, build and run it. So here I get what value? Okay, the until this is the input and 3. Okay, same value still 10 10, but I get 11 12. Okay, 0 1 0, but I get 0 0 10 11 10 11 12 again. Okay, none of those values are accurate for mine. Okay, no problem. So let's read again. So there are no remainders of dividing by 3, so these cases are cover the whole solution. So c1 plus 2 into c2. Okay, in this case, okay, if the remainder is equal to 0, if the remainder is equal to 0, we don't need to gather anything else because the variables. Okay, if the remainder is equal to 0, let's test something with the test cases value. Okay, for example, 30 modulus 3 equal to 0. So in this case I have to print both values same. Fine, then uh, 32 modulus 3, I get 2. In this case I think I did the wrong thing here. I hope I found the bug. I found the bug actually. Not c2 actually, and I have to write this part n, also here n. If I now save this file, also I have to take a look for other test cases. This is 0 and this is 2. For 30, what is the value? Okay, for 1000 modulus 3 is equal to 1. Okay, 1 modulus 3 is equal to 1, then 5 modulus 3 is equal to 2. So I think I get an idea from there. So if the modulus value is 0, so let's go to the code again. If the value of n modulus 3 equal to I think don't need this actually. I can write n modulo 3, sorry, okay, okay. I think this is right from until now. So if the resulting case, if n modulus 3 equal 0, then c1 will be c2. I think here I have to do nothing. So so this condition is useless, I think. Okay, this condition is useless. Just print the value of c1 and c2, which is here, and those values are already equal. So for the second test case, okay, I let me check the value of n divided by 3. So if I divide 30 by 3, so 10. Okay, so this one is correct for in this case. So if the resulting value is 2, so what will be the answer? So what is the 2? 32 modulo 3, 32, this is 32. So this is for this case. So 32 modulo 3. Okay, if I divide 32 by 3, I get 10. Okay, 10 is the value of c1. Okay, 10 is the value of c1. I think I don't need this floor. Okay, or I need this floor here. I don't know actually. 30, 10, and this is the value of 10. So if I skip this and for now, so what will happen? So now I get the value of 10 as a integer value here. So if the resulting value is 2, so I can say c2 is equal to c1 plus 1. Okay, that's fine. And if the resulting value is 1 modulo 3, 1 modulo 3, for example 5 modulo last one, 5 modulo 3 is equal to uh, 5 modulo 3 is equal to 2. So for 5 modulo 3 is equal to 2 and 32, this one is those, both of those values are 2, resulting value is 2. So 2 and this one and this one, so 10, 11, 1, 2. So I can say if I get 2 as a result, so c1 value is the divided value, and the value of c2 is equal to c1 plus 1. Okay, that's fine. And if the resulting value is 1, if the resulting value is 1, for example 1000 divided by those cases, so I can say the c1 value is c2 plus 1. Okay, that's fine. I think my source code is correct in right now. So copy it and test it here. Okay, let's run it. I think I did something wrong. Okay, so this is the input, and okay, I think I get the right answer here. 3334. Okay, I think yes, finally I get the right answer here. So this is my source code. Okay, okay, this is my source code. Here I divide n by 3 and just copy both value as the same. And if I divide if I modulo n divide n modulo 3, if the value is 1, then c1 is equal to c2 plus 1, and if the modulo result is 2, then c2 is equal to c1 plus 1, and finally we print c1 and c2. And here also a test case presented, because what happened if the value, resulting value is 0. So in this case, c1 and both c1 and c2 are equal. So I already did it here, because 30 modulo 3 is equal to 0, and in this case the resulting value is equal, so c1 equal to c2. So if I now submit it, so uh, okay, submit, browse documents, c++ Codeforces 800, polycarp coins cpp. Okay, and this is a compiler selected. Fine. mm, we should, okay, fine, finally the solution is accepted. Okay, this video is from, I will end this video here. See you on the next video. Bye bye.